Hello, hi friends, welcome back. So today we are doing the second module of Telecom Cloud. So in this we will cover that what all are the drivers of cloudification. Drivers mean which things drive CSPs to go for cloudification, or what are the benefits of cloud over a traditional telecom network. So here if we see, uh, the first thing is that drives the cloudification, that is just a minute. Sorry, yeah, the first thing is zero footprint. See, obviously if you see, the cloud is itself a one entity, right? So it caters so many entities, so it reduces footprints a lot. That's why the all the entities to be deployed in the field gets reduced. So this is a one benefit or driver, you can say. The second driver is that the processing of critical functions can be done at the edge. Critical functions, sorry, at the edge. Edge means edge cloud, right? The third one is slicing is possible. Slicing means a dedicated slice for dedicated services. Dedicated slice for dedicated services. I mean, for a particular service where high low latency requirement is there, so accordingly the dedicated slice can be catered for a particular customer as well. If there is an enterprise service requirement, then one slice can be dedicated for the enterprise, like that. So that is. The fourth one is flexibility, software and hardware flexibility. In cloud there is no proprietary solutions requirement, so you can take the hardware of a vendor and you can take the software of another vendor. So that is fourth benefit of cloud. The fifth benefit is intelligence in random access network part. So through cloud or ORAN model, we can put intelligence in RAN part, right? Through RIC, that comes through ORAN structure, that is RAN intelligent controller. This is the fifth benefit. The sixth one is automation. Automation is possible in cloud. Right, automation is possible in cloud, and this automation is very helpful in self-optimization network. Self-optimizing network. And other functions as well, other maintenance functions as well, operations, O&M. The seventh one is that it gives flexibility of open API as well. Open API. So we have the flexibility of choosing functionalities through open API. I mean, any we can choose any API for our application. So these are few benefits, and few more are there. Like so, if we take one more, that is decomposed REN functions. Decomposed REN functions means, if you see the BBU, that is baseband processing unit, BBU. Okay, so BBU does the baseband processing unit in BTS. So what we can do, that we can separate the CU part, DU part, and RU. CU, DU, RU, we can separate. So CU is where it is central unit. You can name it central unit, distributed. This is unit, or RU is radio unit. So we can divide this BU in these CU and DU part through cloudification. So how we can do that? CU functions where there is less, I mean, it caters the less critical functions or processes. Less critical functions or processes. This is present on the edge cloud. So it caters the functions which are time sensitive, or where low latency is required, high processing is required. So it processes that. DU, and RU is radio unit, through which it controls the uplink and downlink, this physical layer protocol, and this which transmits, receives, this transmits, receives, and digitizes the signal. So this is RU. RU is in the end. So we can decompose this BBU into these functions, and these two, CU and DU, can be put together as well, and can be put like this, that CU is here somewhere and DU is near the site, and then RU. So like this. So this benefit is there, that we can do this through cloudification, decomposed network function. So what is the benefit? That the latency gets reduced here. Obviously the distance is shorter, so latency would be less than the latency of this. So suppose we have BBU here, then the latency would be higher as compared to this latency, RU and DU. So that's why this is the benefit for decomposing both functions, CU and DU. Right, next, so if we see OREN, next comes the OREN. So OREN, in February 2018, an OREN alliance was created. OREN alliance. So that OREN alliance consisted of few telecom players across the globe, which made the protocols and system for this OREN, like a 3GPP is there. So like that, OREN is there. So that OREN decided the open interfaces, open APIs, and all that, how they will work. So broadly, if you understand that this OREN, this is RU, this is DU, this is CU, and then this is core, right? We can say this aggregated edge cloud, this is edge cloud, far edge cloud, we can say the far edge cloud, and this is RU. So this is front hall, this is mid hall, and this is back hall. So this front hall is, you can say, open interface. So these things are decided through ORANs, that what type of protocol and all would be there. So if you see this, there are work groups, many different work groups, like work group 1, work group 2, work group 3, like this. There are total 11 work groups are there, and those work groups are working on different topics. Like work group 1 is looking after the overall architecture, this work group 2 is looking after non-real time, this work group 3 is looking after near real time, like this. So different functions are divided. So broadly you can understand that there are 11 work groups in ORAN which are working for standardizing this ORAN. Now, what is Cloud RAN and Open RAN? Are they different? Are they same? Or how they are different? See, Cloud RAN and Open RAN, they can work together and they can work separately as well. So if you understand, Cloud RAN gives you vertical flexibility. This is hardware, like this is SaaS, container as a service, or you can say hardware, then this is container as a service, or you can say stack layer as well, cloud layer. Then this is VDU, VCU, virtual distribution unit, virtual central unit, and after that whatever like this. So cloud gives you this flexibility that you can use any hardware, you can use any software, right? You can use containerization as well. And in ORAN, this gives you, ORAN means Open RAN. So Open RAN gives you horizontal flexibility. Like this is UE, and UE is connected to RU, and RU is connected to DU. DU is connected to CU, and CU is connected to core. So you can have any vendor A, you can have RU from vendor A, you can have DU from vendor B, you can have CU from vendor C, like this. You can have different vendors in this Open RAN. So that's why it is called Open RAN. So this is a horizontal flexibility in Open RAN. Right, so here EC3, this is front hall, this is EC3, this is mid F1 or mid hall, you can say, this is back hall. So basically the difference in this Cloud RAN and Open RAN is this only, that it gives you vertical flexibility, and this is called Open RAN because you can use any vendor for RU, DU, CU. Fine. So let's come to next. So these are the these were our few benefits of this Cloud RAN, or the drivers which drives CSPs to go for this cloudification of their traditional network. So if we see next, if I tell you this is far edge cloud. Let me draw a rough diagram of the cloud network. This is DRAN. This is again a far edge cloud. It could be, CRAN, you can say F1. This is NRT, near real time. This is aggregated cloud. This is a broad, this DRAN or CRAN could be in a same cloud as well, right? This could be in a same cloud as well. So it has a flexibility here. You can say RE, whatever. So it depends upon the distances and how do you want. If you want this DU near site, if you have low latency requirement, then you can put these this DU near site and far away from this CRAN. Now slicing. Let's come to slicing. What is slicing? So in slicing, what happens? Suppose this is VCU U. This is UPF function. This is VDU, right? And this is another cloud. Here it is VCU C. So this is control plane. This is user plane, right? And here also VDU. And VCU U, VCU U. Now suppose here is one XR or virtual reality. There is requirement of FWA as well. There is requirement for some enterprise. So there are, suppose 3 slices are there. So these 3 slices, so if suppose this slice, let me draw it different color. This slice requires very low latency. So the processing of the user part would be done through this cloud, that is the far edge cloud. And this is a different slice. Suppose this one is different slice. So there is no requirement of ultra low latency in this. So this slice can be, the user part of this slice can be catered through this aggregated cloud as well. So it all depends upon the requirement of that, what kind of service you require in the slicing. This is how the slicing part is done. So slice, you can say slice is a dedicated service for a dedicated requirement, like this. So you can say the XR slice is served by this this far edge cloud, and these 2 slices can be served, the user part of these 2 slices can be served by this one. Now if you see, if broadly we see the 5G benefits, then what are the benefits of 5G? That the capacity is greater than 10 Gbps, connectivity is devices per kilometer, this much devices per kilometer. This is too much. And the latency must be less than 1 millisecond. Radio latency, that is. So these are the broad requirement of 5G, that the 5G should give at least these services, that it should connect this much, 1 crore 10 million approximately devices per kilometer, and the speed must be, the capacity must be greater than 10 Gbps, and it should be the latency should be less than 1 millisecond radio latency. So the key drivers, right? The key drivers, what are the key drivers? So the key drivers for cloudification, what are the benefits of cloudification are flexibility of hardware and software. Right. Infra and applications are the cloud native benefits, availability, flexibility, power consumption, loosely coupled as infrastructure, agnostic, automatic. Low latency, low latency services. The third one is automation, intelligence in the network. So these are the broad benefits of cloudification of the network that encourages CSPs to go for it. So that's it for today's session, a broad understanding of benefits of cloudification and what drives CSPs to go for cloudification rather than traditional network. Fine. So we will cover something else in our next session. Thanks.